Welcome to an example in which we have bearings. The HMS Sasquatch leaves port on a bearing north 22 degrees east and travels 4 miles. It then changes course and follows a heading south 38 east for 2 miles. How far is the ship from port? Okay, so on these kind, you always need to draw an axis system to see your situation. So I'm going to start down here, and I'm going to draw a little axis system that has, that's hopefully a little better than that. That's the best I can do. So north, south, east, and west. That's an N there. And so this HMS Sasquatch, I guess that's a ship, is heading, what direction? North 22 east. So that's like that. So so it's north. So it's headed, north, but not pure north. 22 degrees to the east of north, right? North 22 east. And it does that for 4 miles. It heads off in that direction for 4 miles. And then right there, it's going to change its game plan. So I'm going to put another little axis system right there. And where's it going to head to? South 38 east. So again, north, south, east, and west. South, but not pure south, 38 to the east of south. So I'm going to go, okay. To do for 2 miles. Like that. Oh, whoops, didn't use my tool. About like that. Okay, so stops here. Does that for 2 miles. And you see the angle I just made there? Let me be clear on this. Here's straight south, right? This is straight south. This thing is south, but not straight south. 38 degrees. Yeah, let me, if I have room to put it in right here. 38 degrees to the east of south. Does that make sense? That's the direction it heads off in the second time. South, but not straight south, 38 to the right, to the east of south. Stops there. So the question becomes, how far did it travel? How far is the ship from port? So what they mean is, how far from here to there? Right? Because this is port here. I'm going to find that X there. This is port. This is where they started. And then went northeast and then southeast. And then where did it end up? How far is it from port? What is that distance X? Well, basically we're going to do law of cosines. We have this side and this side. We just need the angle in between. When you have two sides and the angle in between, you can use law of cosines. We've done it many times. So how do we actually find this entire angle in between? We have this part's 38, but we don't know that part there. So we've got to find that part there. How do we do it? Let me give you 2 ways to do it. These are called Z angles. You see those two? That means this angle must match that angle. If you see that and know that from geometry, they're called alternate interior angles. I call them Z angles. The technical name is alternate interior angles. They're always equal. That's got to be 22. Because this line and this line are both straight up and down. That's both the north-south line for both axis systems, right? I'm doing the north-south line here and the north-south line there. And then if you cut them like this angle has got to match that angle. I call them, when I teach geometry, I help my students see it by calling them Z angles. This angle and this angle have to match. So that has to be, that one in there, this one right here has to be 22 degrees, just like that other one. So let me write the 22 up here. This has to be 22 degrees right there. Therefore, the entire angle from there to there is 22 plus 38, which is, what's that? 60 degrees. Right, that came from 22 degrees plus 38 degrees, which is 60 60 degrees. So that's the entire angle right there has got to be 60 degrees. So that's what we can do. Now there's other ways. If you don't like that Z angle thing and that's a little confusing for you, you can work a little harder. Here's the other way. Let me give you another option in case that kind of bugs you. You can come up here and you can just make a right triangle and say, well, look, this is 22, this is 90. So if you take 180 minus 90 plus 22, right, because triangle has to hold 180, you'll get, what is that got to be, 68 degrees right there. That's got to be 68 degrees. And then you can find this part, because together they've got to make 90 because they are west and south. They got to make 90. So indeed, it's got to be 22. That's the other way you could do it instead of the Z angle thing. 22 and 38 make 60. So now I've got this entire angle here is 60 degrees. And that is across from x. I got these two sides. I can do law of cosines. Remember law of cosines? I'll go on up to it for a second. There it is. Law of cosines. Remember we had 3 different versions. It's always a across from a, b across from b, c across from c. So if a is across from a and then the other two, b and c, are in between. Or if b is across from b, then a and c are in between, etc. You always have a side and the angle opposite it at the beginning and end of law of cosines. So let's go back to the problem and do that. So we know now that x squared has to equal, in fact, let me bring it down a little bit right here. X squared has to equal the other two sides, which is 4 squared and 2 squared, minus 2 times 4 times 2 times the cosine of the angle in between, 60 degrees. See how? X is across from 60 degrees and X is across from 60 degrees. And then these are the two sides surrounding the 60-degree angle. So that's how you use law of cosines. All right. I'm going to crank all that on my calculator right now. I'm getting 12, which is nice. Square root both of those. X equals, because we got to get regular x, not x squared, 3.46 nearest hundredth. That's as far as they want. 3.46. The distance, 3.46 miles. So there we go, using the law of cosine.